Okay, so for our next question here, factoring by grouping, we want to look at our first two terms and our last two terms, and we want to take the greatest common factor out of the first two, which in this case happens to be a 3n to the second. Both terms have a 3n to the second, and if we factor out, we will end up with a n minus 3 on the inside of the parentheses. Over here, we have a greatest common factor of 2 in both of these two terms, and we could factor that out to give us a 2 times n minus 3. So at this point, we have two groups that have the same factor of n minus 3 that we can factor out of both groups. So let's factor out the n minus 3 from both, and that leaves us with 3n squared plus 2 times n minus 3. Look at our next question. We have to factor the quadratic. Factoring a quadratic like this is similar to factoring with degree 2. And we have to ask ourselves, what two numbers multiply to make 24 and combine to give us a negative 11? An 8 and a 3 will give us a 24, and they will also give us a negative 11 if they're both negative. So what two terms will multiply to make up x to the fourth? X to the second times x to the second. On this one here, we have to factor the greatest common factor and then factor the remaining polynomial. So we have to factor the biggest term out of each one of these to start off. So it looks like we have an x and two m's in each. So we start off by factoring that out of all three. So doing that, we now have a polynomial that we can factor. And once again, we ask ourselves, what two numbers multiply to make up 21? And the difference between them is a 3. And I am finding another typo, kids. Let's make this a 4. So what two numbers? Well, 3 and 7. 3 times 7 is 21. The difference between them is a 4. We're going to have a 8. We're going to have a x to the fourth times x to the fourth, giving us an x to the 8th power. We need a plus 7 and a minus 3 to give us a plus 4 there. All right, so our next set of questions deal with dividing, long division with polynomials, and we have to set this one up first. We have to divide using long division, and so I'm going to set this one up. So we have x to the third minus 2x to the second, and then we have a minus 4, but I don't like that we jumped over the x to the first, so I'm going to add in a 0x to the first as a placeholder, and then divide from there. That gives us a nice layout when we actually do the long division. So the first thing I ask myself is what times x is going to give me an x to the third power? What times x is x to the third power? X to the second. So I'm going to multiply the x to the second times both of these terms in the divisor. X to the second times x is x to the third. X to the second times negative 3 is a negative 3x to the second. So we subtract that quantity. And we distribute in the negative. That gives us a x to the third minus x to the third, which cancels. And that gives me a plus 3x squared minus 2x squared, which gives a x squared. And we drop down that 0x placeholder. So now we ask ourselves, what times x is an x squared? What times x is x squared? That is x. X times x is x squared. We have to multiply x times minus 3 as well. And then we subtract that quantity. Distribute in the negative. That gives us a minus x squared plus x squared. They cross off. And then distribute the negative here. That gives us a plus 3x plus 0. and then drop down that 4, that negative 4. We ask ourselves, what times x is 3x? What times x is 3x? A 3 times x is 3x. So let's go ahead and multiply the 3 times both of the terms in the divisor. That gives us a 3x minus 9. Now we subtract that quantity and we distribute the negative. 3x minus 3x cancels, and minus 4 plus 9 is a 5. So our answer is x squared plus x plus 3. That's the quotient plus the remainder of 5 over the divisor of x minus 3. Now that's not all I want. I want you to actually show that what you found is correct using the division algorithm. The division algorithm says that when you multiply the quotient times the divisor, you will add the remainder and get the dividend here. So here in blue you can see my work, and I've multiplied and added, and I see that I indeed will get the dividend. Let's look at the next one. So we have to divide using long division. I'll go ahead and give you the setup and then walk you through. Okay, so let's see here. We have to divide, and we ask ourselves first, what times 2x is going to give us a 2x to the third? What times this term here is going to give us this term here? The first thing I'm asking myself. I see that 2x times x to the second will give me a 2x to the third. So let's multiply the x to the second times the 2x and the plus 3. So that gives us a 2x to the third plus 3x squared. And we subtract that quantity. Distribute the negative, and that's going to give me a 4x squared here. I drop the 2x down. So now we ask ourselves, what times 2x is a 4x to the second? What times 2x is 4x to the second? 2x. 2x times 2x is 4x to the second. Remember, multiply the 2x times the 3 as well to give us a 6x. Subtract that quantity. Distribute the negative, and that's going to give us a 4x minus 4x here. Drop that 9 down. What times 2x is a negative 4x? Negative 2. We have a minus 4x minus 6, and we have to subtract that quantity, and that's going to give us a remainder of 3. So our answer here is quotient plus the remainder of 3 over the divisor. And once again, I want you to check using the division algorithm. I'll show you that very fast here. The division algorithm says that the quotient times the divisor plus the remainder should give you the dividend. Let's go ahead and see that fast here. So I went through and I used the division algorithm, and I found that I didn't come up with the correct divisor. So I did some backtracking, and I realized, if you guys were to rewind a little bit, that I found the incorrect remainder. And so that tells me that I have to go back through. And I actually subtracted instead of added. I should have found a 15 for the remainder. So let's see, when we add 15, we should end up with the right answer when we use the division algorithm. And minus 6 plus 15 is a 9. This will check out. So the division algorithm is really helpful in determining if we have found the correct solution or not. And it definitely caught me. So let's move on. All right, so our next set of questions deals with radical form and square roots. And our first couple questions, you literally just have to go in between radical form and exponential form. Here we have 9 to the negative 2 over 3 power. We have to write in radical form. So I notice that I have a negative exponent. I don't want a negative exponent. I want to deal with a positive exponent. So I'm going to write 1 over 9 to the 2/3 power. Now from here, I end up with a root, a third root because of the 3 in the denominator, third root of 9 to the second power, and that's under a 1. Let's look at the next one. I have to go from this root form to exponential form, and so first thing I'm going to do is write that 7, and I have root 5, so that tells me the 5 is in the denominator and the 3 is in the numerator. And that's it. That's all we have to do for those ones. Our next one, we have to take the square root. Now, there's nothing in the pocket here, so that means that it's a square root question. We have to identify doubles. So I'm going to go through and I'm going to identify the doubles of this. Okay, so 300 is 3 times 100. I have a double here with 10 times 10. I can pull 110 out. And then here, I have x to the 6. That's x squared times x squared times x squared. So I have one double that I can pull out there. I have another double that I can pull out. I have another double that I can pull out. And then I have y to the 8th. That is each one of these y to the seconds multiplied. I can pull out. I got 4 double y's. And then finally, I've got 5 double z's that I can pull out. And I am left with the 3 under the root. So my final answer, I have 10x to the 3rd, y to the 4th, z to the 5th, root 3. Let's look at our next question here. We have the third root of 27, x to the 6th, y to the 9th, z to the 12th. Third root tells us we have to identify triples multiplied. Pull out the triple. So let's go ahead and break this down and see where we have triples. Okay, so I've broken this problem down into triples. We have 1 triple 3 we can pull out. We have 2 triple x's we can pull out. We have 3 triple y's we can pull out. We have 4 triple z's we can pull out. And we're left with nothing under the root. So the root goes away and we're left with 3x to the 2nd, y to the 3rd, z to the 4th power. So on this question here, we have 16x to the 8th, y to the 16 to the 3/4 power. What helps me is to think about this like so. We have 16x to the 8th, y to the 16 to the 1/4 power times 3. So I'm thinking, what's the 4th root of 16x to the 8th, y to the 16? What's the 4th root of that? And then raise whatever I have there to the power of 3. Okay, so I've identified where we have something multiplied 4 times. We can pull out a 2 x's, and 4 y's. But then we have to raise that to the 3rd power. So 2 to the 3rd power is 8. And then we have to multiply exponents there. X squared is x6. And then y to the 4th, y to the 4th, y to the 4th is y to the 12th.